Igor is presenting a merge request walkthrough on support for SSH signed commits. Igor, please take it away.
Yeah, hello everybody. So just let me start why we actually had an urge to implement it. Yeah, because this topic commit sign-in we had it before, but actually GPG keys were used for sign-in like a year ago. So okay, like a year ago, it started being possible for Git to use SSH keys to sign commits. So actually, Brian Williams, was enthusiastic about this topic and decided to implement it. And actually, he implemented everything by himself, and currently. And we just had to implement it like a couple of issues in order to make it work. And why it started being important like a couple of months ago, it's because one password started supporting SSH keys. And if, for example, someone has like one password extension, like Chrome extension, it started being super easy to configure like an SSH key and use that SSH key for signing. For example, if we have a look at the profile keys page, and if we want to add an SSH key, one password extension actually suggests a couple of drop downs to create an SSH key, but let's use an existing one, for example, this one, and add it to GitLab. Yeah. When we edit it, we actually have it in one password application available. And if commit sign-in is not configured system-wide, one password actually even suggests to configure it for you and has some more suggestions. But since I have it suggested, it can be also viewed in the settings, and it provides some useful options to configure commit sign-in. It can be either edited automatically. This content will be added to your Git config, or it can be copied and edited manually. Let's have a look what does it actually means in the Git config. Like a signing key must be provided. It's actually the public part of the SSH key that is used for commit sign-in. Also, in format we say that we use like SSH sign-in commits. In this GPG SSH option, we specified a program that is actually used for commit sign-in. By default, SSH like SSH key generation utility is used, but one password also provides its custom SSH sign-in utility, which is also really handy. And this option is just mentioned that I want to sign every commit. So let's actually try and create a commit and sign it. Let's see how it actually works. So let's edit like this file, add some text. So we have these changes. Let's create a commit sign. And it's also one password asks you confirmation to sign the commit. So it actually works like this. And now our commit is signed, and it can be viewed by using show signature option for Git show. It actually shows that commit signature is that this commit has a good commit signature with this particular fingerprint. And let's try and push this commit and have a look at them. So now we have this commit. Let's check the ID, like it's like 31 here. Yeah. So now the commit is verified with this particular fingerprint, particular signature. And now we see that it's actually works, and now a commit is signed and verified on GitLab site. So with 1Password, it becomes pretty easy, and 1Password like suggested this collaboration, so we decided to urge it a bit and implement it as soon as possible. But it's actually can work even without 1Password, using like SSH keygen utility and Git and like your SSH folder, which contains the SSH keys. So let's have a look how it actually works. Sorry, Sean, I haven't noticed your hand. So if you have a question, I'm ready.
Yes, I do. No problem, and it's a good time to ask it. So, so I'm familiar with, for example, the SSH folder, where you create the keys and then you upload those keys to GitLab, for example. But when we're using 1Password, how do the keys? Does it generate the keys inside of 1Password, or do you generate them first on your local file system and upload them to 1Password?
Yeah, like for this particular case, if we have a look, if we click like create an SSH key, it's actually like create and fill an SSH key. It will generate one, and it will be stored like
only in 1Password.
Inside 1Password.
Okay, that's a great feature. Okay, great, thank you.
Yeah. But it can be also manually generated and uploaded, and just as usual stuff.
Great, thank you.
So how it actually works. So we have object ID, and we can use some low-level cat file git command, which actually shows us some raw data for the commit object, and it actually shows some data about the commit, about the author committer, and also has this raw signature. Cat file is actually used for low-level command, and like Gitly quite widely uses this command because like it's low level, more flexible, and for performance reasons they like often use the cat file and parse it. So what it actually shows, like commit data and its signature, and by default SSH keygen utility is used, and this like sign command, it's actually used by default, and Git just basically performs this command under the hood, and in order to create a signature. It's just name of the command, like sign, it's like a namespace, that's a Git namespace, and also provides a key which is used for signing. In this example, private key is provided. I just exported this key from 1Password and stored in the downloads folder just for convenience. Like private part is used here. But if we have a look at the SSH key generation utility documentation, it says that a public key can be used if the private half available in our SSH agent. So why I decided to mention it, just because if we have a look at the Git config, we provided the public part of the SSH key. So in order to avoid flashing our private key everywhere, we just provide the public key here, and it's just used for commit signing. So, but let's just use the private part here and try to encrypt the content of the commit. Actually, like this part and this part is used for encryption, for signing. So let's just create, just a second, I'll create like message txt and fill it with the commit data. So like this, and now we try to sign it. We received this file. Let's see the content of this file, and yeah, it's actually the same as the one stored in the Git object. So this commit data is signed using our private key, and we receive this signature, which is also stored in the Git object and pushed to the server. And we can use this signature in order to verify that the data and signature is correct. A quick note regarding this signature, it also contains some metadata about the key that was used for signing the commit, because if we again have a look at the commit using show signature option, it shows that like good Git signature for this particular email using this particular algorithm, using this particular public key fingerprint for signing. And this is actually the sign-in part. And let me also show you this diagram of how it's actually like cryptographic sign-in actually works. We have a data, we have private key, and we have a public key. And we want to sign this data and verify this data. We have the data. The data can be really large. In order to somehow limit the data, we use hashing function to create a smaller hash of this data. We created a hash. We have private key and signature algorithm. We use signature algorithm and the private key in order to encrypt this hash. And this encrypted hash, encrypted content, it's actually our signature. Data is public, signature is public. Now we want to verify that data matches the signature. We have like data and hashing function. We use the data and hashing function to calculate the hash. We have a signature and the public key. We use verification algorithm and the public key to get the hash from the signature. Then we just compare that two hashes match. If they match, the signature and data is correct, wasn't corrupted. And if they doesn't match, that the data or the signature was corrupted. So yeah, let me pause, and if you have a question regarding the sign-in of this topic, so feel free to ask. No, Patrick?
Yeah, I have a question about which algorithm did you actually use to sign the data? Because I see that you will have the same encryption every time with the same content. So I thought that might be a security risk, even though it's very unlikely, but it might then be, it's exposed to a brute force attack. So
we have a private key. Yeah, we have a private key. So this part is private. Yeah, and if we use this private key and like a particular hash, so like with different private keys, we'll receive different data. And the point of cryptography, yeah, that it's actually hard to enumerate, yeah, hard to guess the private key from the content, yeah,
from the
it's actually
private,
hard, like infinitely hard, and yeah, and that's why we should use like a public key to actually decrypt the data.
Yeah, I forget, it's probably RSA. So if one bit of the content change, the whole private key is gonna change. So yeah, you can, yeah, it's hard to brute force anyway. So yeah, I forget, it's probably RSA then.
Yeah, that's actually a good question, and that was yeah, that was I actually wanted to mention. Yeah, thanks for mentioning it. Why I was nervous when I run this command, because if we, for example, forget to, if you, for example, leave like a new line somewhere here, the content will be completely different.
Yeah.
Kind of hard to debug. So if, for example, we didn't have this signature matched to this signature, yeah, I would be in panic right now. Yeah. So
okay.
Yeah, great question. Yeah, thank you very much. So yeah, now we need to verify the signature, the data on GitLab site, and let me see. And we have this class, which actually, yeah, like the most interesting part here is this class, and it's responsible for verifying that our signed data and signature, the signed text and signature text actually matches. I think like the best way to have a look at this class is to run the test. So I have a couple of bindings. So let's try and run the test and see the internals, how it actually works. So okay, why it's running, like we using this class, we set the verification status like data. We check that the signature is correct, and in order to check it, we actually use the signature text provided by GitLab. This signature text is actually our content here. So if we have a look at this signature text variable, we have like this signature. We use like this gem to parse the data. If we parse the data, we have like a signature, we have the public key. As I mentioned before, this content actually stores this data, and like we have the fingerprint, the public key that was used for signing this text. So we have public key, and also hashing algorithm is provided here. Let's go further. Now we need to verify that the signed text actually matches the signature, and like gem provide the verify method, and we send the signed text feed the signed text into this method, and this gem just verifies that this text actually it actually matches. Yeah, like this part here is executed. Yeah. Now we verified that our block is valid. Now we need to find the now we need to find the SSH key that was uploaded to GitLab in order to match the content to the user. So we use this signature, we use this public key fingerprint in order to find the key. Key is a table is a model, a table for SSH keys. We try to find it, and we find it, and this particular key record, and it also has a user linked to this key. And if we have a look at that, we have a user, and now we can verify that this user's email is actually the one specified in the commit. And if it's the same, we say that the commit is verified. If one of these steps fails, then the commit is not verified. So I think that's it. Let me quickly check. A couple of, or maybe if you have questions for this step, so I'm happy to answer them. Yeah, so maybe it looks not very complex, but like the code around it also, we had to also take into the account that these signatures, they should be stored because if, for example, someone removes SSH key, and SSH key, the commits should stay verified. So if the commit was already verified, it should still show the badge that it's verified. So this data is stored in the database. We also have currently an issue in progress that if, for example, an SSH key was compromised, there's a chance that's, sorry, yeah, Vasily?
Yeah, I just wanted to mention a couple of things around the same topic because recently I was reviewing some of the MRs related to that. So one of them that we also have, it was a surprise for me that we have a signature for tags. And I think there we support only this X something numbers algorithm, not SSH. Might be also a good option to see if we can support like SSH for them as well to match the functionality of the commits and tags. And another one was around the signature from the GitLab side. I think there is an issue around that, and the community contributor tries to implement that. So the commits automatically generated, for example, the merge commit that GitLab generates will be also signed with the and verifiable. Sorry.
Yeah, that's a great point. Yeah, because for example, when we create a local commit, yeah, it can be signed. But if, for example, we use web ID or, for example, squash commits or merge commits, they are generated by GitLab, created by GitLab. So we actually, plan to have like an SSH key pair uploaded, like system-wide, and then use this SSH key, or for example, GPG key, in order to sign the commits and verify it. Yeah, so and like we see the verified badge that the commit was created by GitLab. Yeah, that's a great point. That's also like some work in progress, and it's actually a good contribution because we also have a setting which is called not the setting, but like, okay, we have a push rule that we can reject every commit that is not signed. So if we set this option, now like web ID commits or merge commits can be accepted because they are not signed. And that's actually like a blocker for enabling such an option globally. So yeah, Vasily is right. It's like this part is an important work in progress, like revoking an SSH key is also work in progress, because if an SSH key is compromised, someone can create some signed commits, and we want to mark those commits unverified. So when an SSH key is revoked, we not only want to remove that key, but also mark all the commits that were signed using that key as unverified, because those commits are also could be compromised. So this work in progress.
Excuse me, Igor. Sorry, I do need to drop off. I'm
Yep.
recording, so I'm going to stop the recording, but I think you can continue the conversation. I'm sorry, I have another meeting to get.
I haven't noticed that it's 4 o'clock already. Yeah, I'm
Yeah.
sorry.